Have you ever struggled with detecting shapes in images, only to find that traditional methods just don't cut it? If that sounds familiar, you're in the right place. Today, we're diving into quadrangle and rectangle detection using convolutional neural networks. I completely understand your frustration. Many of us have faced the challenge of getting accurate shape detection in real-world images. You're definitely not alone in this struggle, and it's a common issue in computer vision. Let's take a closer look at your specific situation. You mentioned trying classic methods like OpenCV, contour detection, and Hoe transform, but they just didn't work for your images. You then turned to convolutional neural networks, but you're still seeking a robust solution for quadrangle detection. Sound familiar? Let's explore this together. So, what makes quadrangle detection so tricky? Real-world images often contain occlusions and varying perspectives, which can throw off traditional algorithms. Understanding these challenges is key to finding a solution. And stick around. I have a unique approach to share at the end that could change the way you think about this problem. To begin with quadrangle detection using convolutional neural networks, the user should first gather a dataset of images containing quadrangles. This dataset should include various angles, lighting conditions, and occlusions to ensure robustness. Next, the user should label the images in the dataset. This involves marking the four corners of each quadrangle in the images. Tools like LabelIMI or VGG Image Annotator can be helpful for this task. After labeling, the user can proceed to design the convolutional neural network architecture. A good starting point is to use a backbone model like ResNet or MobileNet, followed by custom layers to predict the four corner points. Once the architecture is set up, the user should train the model using the labeled dataset. It's important to use a loss function that minimizes the distance between predicted and actual corner points, such as mean squared error. Finally, after training, the user can evaluate the model's performance on a separate test set. This will help determine how well the model can detect quadrangles in real-world images, including those with occlusions. Fun fact, did you know that the first neural networks were inspired by the way our brains work? It's fascinating how far we've come in technology. Now let's look at the answers provided by other users. An alternative approach suggests starting with contour detection, followed by applying a state-of-the-art Hoe transform to detect rectangles. This method addresses the issue of occlusion by adjusting parameters to be more forgiving of missing edge pixels. Additionally, the user recommends checking recent contour detection methods, such as those discussed in a CVPR paper, to enhance the detection process. Here's a tip. Experiment with different architectures and training techniques. Sometimes the best solutions come from trial and error, so don't hesitate to iterate on your designs. And there you have it. With these strategies, you're well on your way to achieving robust quadrangle detection. Remember, persistence is key. If you found this video helpful, please subscribe for more insights and tips.